So the next piece we are looking at is exponential functions. An exponential function is basically a number to a power. The ones we are focusing on today are going to involve e's. So this is just kind of, if you're interested, you know, the number e, it has a value kind of like pi. This is where it comes from. You don't necessarily have to memorize that. I've just kind of thrown that up there. It actually has to do with the limit. That's how the number e is defined. When we did exponential functions, they all kind of look the same. You know, 2 to the x, 3 to the x. E is like a 2.7, so it falls in between those. If you remember those exponentials, they all had a horizontal asymptote of the x-axis. They went through the point 0, 1. And if the base were positive, it was increasing. If the base was bigger than 1, it was increasing. If the base was smaller than 1, it was decreasing. What you really need to know today, we will eventually get to all of the other exponentials, but we're starting with our favorite one in calculus. And this one has to do with the way e is defined because it works with that limit definition. The derivative of e to the x is e to the x. It does not change. Okay, so that is something you just have to know from here on out. Okay, so here's a function. I want to find f prime and f double prime. So we go term by term. Derivative of e to the x is minus, what's the derivative of x? 1. Okay, second derivative. Derivative of e to the x is, what's the derivative of 1? 0. So that is our second. Okay. Any questions on that one? I put on here for you to compare the graphs of f and f prime. I just wanted you to see the relationship. So if you want to grab your graphing calculator really quick. So I'm just going to put in my y1, the original function, e to the x minus x, and my y2 will be the derivative, e to the x minus 1. Okay, and we see it has all of these same properties of derivatives that we've already talked about. You know, the original starts out kind of like this. So it was decreasing, so when you look at the derivative, it was negative. Here it would have had a horizontal tangent line, so the derivative was 0. Increasing, so the derivative was increasing. So all the same properties that we've talked about with our graphs still hold true here. All right. Is that one okay? We just have about 3 examples left, and then we're done with this section. At what point on the curve y equals e to the t is the tangent line parallel to the line y equals 2x? What does parallel mean? Same slope. What is the slope of this line? 2. So how do I find the slope of the tangent line? Yeah. Slope of a tangent line is the derivative. So I'm going to do the derivative of this. What's the derivative of e to the t? E to the t. Okay, try to, I just want to really encourage you guys to use proper notation here. As we move forward, derivatives are going to be something that we do a lot of, and we will use the derivatives for a lot of different things. Try to label your derivatives. You know, I don't want to just see like 3x squared plus 2x minus 1 equals 6x plus 2, because when we move forward, that's going to become really, really confusing to you. So if you did that on your homework, then just picking up the next spot, make sure you're labeling like this is y, so this is y prime, because later on we may have like first, second, third derivative all in a problem, and we're going to have to go back and look at the first derivative to find something and the second derivative to find something, and if you don't label them, that's going to become very confusing. So try to label those, please. Okay, so I have an equation for my slope of the tangent line, and I want that slope to equal 2. So in other words, I need my derivative, e to the t, to equal 2. Going back to your college algebra days. Solving an exponential. Do you remember what we add to this problem to cancel that e? Natural log, yeah. You have an ln to each side. The natural log and the e cancel one another, so you have t equals the natural log of 2. Okay, the actual question asks for what point, so if I wanted an ordered pair, this is like your x value. If I wanted my y, if I plug that in, y is e to the natural log of 2. But what do you know about an e and an ln? So my y value is just a 2. That is the actual ordered pair where the tangent line is parallel to the line y equals 2x. The last 2 slides on here are just more practice with derivatives, but they're ones that you may have to simplify a little bit first. So I would like for you to take a couple minutes and try these 2 problems, please. Simplify first, then do your. So, using good notation, I'm just simplifying this first, so I'm still labeling it as g to the x. If there is a radical, remember to write it without a radical, you do the power over the index on the radical. So that's a 1/3, since it was on the bottom, that's x to the negative 1/3. So this is just my simplifying piece, rewriting it so it's all something to a power. So the derivative. Exponent comes down, so negative 1/3, x, subtract 1 from the power, so that's negative 4/3. Plus, what is the derivative of e to the x? Plus, okay, it's x to a power. Now, that power is ugly, but it's just a power. So exponent comes down, so e comes down. X, you subtract 1 from the power, so it's e minus 1 power. E to the third, it's a constant, so its derivative is 0. So this is my derivative there. Questions there? Let's simplify this mess first. Okay. Let's go term by term. This is like an x squared times an x to the 1/3. When you're multiplying those x's, what do you do with their exponents? Add them. So 2 plus 1/3 would be x to the 7/3. Plus, this is an x times, if there's no index here, it's 2, so that's x to the 3/2 power. So again, if you add those exponents, 1 plus 3/2 is x to the 5/2. Minus, if I square this, radical 2 squared is 2x squared. On the bottom, power to a power, what do you do with those? Multiply, so x to the 4/4. All right, I'm just using exponent rules and simplifying. Are we okay with that step? The second step I need to do, I cannot do the derivative if it is a fraction. But since there's only one term on the bottom, I could simplify by putting each one over that term. Rules of exponents, if you have it on top and bottom, you just subtract those exponents. So 7/3 minus 4/3 is 3/3, which is just 1. 5/2 minus 4/3 would be x to the 7/6. 2 minus 4/3 would be x to the 2/3. So I simplified that step by subtracting exponents. Now for my derivative. So notice I'm labeling this as f prime. I don't just have a string of this equals this equals this. I'm trying to label my work. Label when you do your derivative. What's the derivative of x? 1 plus exponent comes down, so 7, 6, x. Subtract 1 from the power, so that will leave me with a 1/6. Minus 2 times 2/3 is 4/3. X, 2/3 minus 1 is negative 1/3. So algebra first, and then the derivative is really simple. Much easier to try to clean them up beforehand than trying to come up with some fancy method of getting the derivative otherwise. Questions? So this homework is due tomorrow. You should have already done the first up through 29. So that would just leave you the last 7 problems. And we will grade that first thing tomorrow and start the next